Good morning and welcome to Race Industry Now. I am Francisque Savignan, the founder and CEO of ePortrait, the global platform for the performance and racing industry. This episode is presented to you today by ARP, Performance Plus Global Logistic, Peak Performance, Shop Monkey, and Fifth Third Bank Motorsport. This is going to be episode 333. And we're going to be talking with SFI by Xcentrick Innovation. With me this morning are Judy Kin, the co-founder of ePortrait, and our wonderful host, Mr. Jeff Hammond. Judy.
Thank you, Francisque, and thank you everybody for joining us today. Today's kind of special because Reggie Huff at SFI Systems is more or less a newer company, and this is the perfect example of a company that comes on board, and this platform really creates an even playing field between a company like Reggie's and a company that's been around for 55 years. So it's not about how big your booth is or where it's located. It really creates an even playing field in the platform and all that we offer. So we're excited to have Reggie on today. This will be very technical. Good morning, Jeff.
Good morning, and good morning to both you and Francis. And the thing is, folks, I've had an opportunity to speak with Reggie prior to today's webinar, and I'm real excited about it. I think he has definitely hit upon something that I guess you'd say, if you want a guarantee, this man is willing to give you a guarantee on how much he believes in his product and the simplicity of what it does do and what it doesn't do. And after last night's conversation, I can't wait to the one we're getting ready to get into here today. So everybody, please remember one thing: questions are good. We need to ask our host and our guest anything and everything, and that's what it's all about. And I'd like to welcome our guest of the day, Reggie Huff. Pleasure to see you, sir, and I hope you're doing good. And I think from South Dakota.
Yes, Brookings, South Dakota, and we finally have some sunshine today. It's been a long winter.
Well, it has been for around the country for sure. And Reggie, I'm just going to go ahead and let's get at this, because I hope that, because of what you're getting ready to show us, we're going to have a lot of participation from the folks that are with us today. And I enjoyed the conversation last night. So let's just pick it up where we kind of left it off. The title for today's webinar is Naturally Supercharged Port Fuel Injection with Tunable Port Airflow. Yeah, so that's a mouthful. So let's get to explaining it.
Okay. Well, before I get to the reason that we use the term supercharged, I need to explain the technical term that aptly describes what this actually does, and that is hybrid fuel injection. And as you and I talked about last night, the thing that's kind of neat about this is that this steals one of the principles from a carburetor. So we have pressure pump assisted fuel injection today that we run primarily in port fuel injection is what we're dealing with today. And that is the best system. GDI is, in my opinion, is a step backwards from that. So we've got that capability. But it turns out that when you add the Venturi effect to that fuel injection, then you use the energy inside the port to create that pressure differential. You can grab that fuel coming out of that injector, which is being highly atomized, so it's slowing down, and literally slingshot it to the end of a nozzle that's much closer to the intake valve. And with that energy, we can shear the fuel. We can actually create better atomization by the time it comes out the other end than the fuel injector nozzle can do. And some of the time, if the conditions are right, we will actually vaporize the fuel. So we can create an improvement by hybridizing, by taking the old concept of the Venturi carburetor and adding a little one to each individual injector. So you basically end up with like 8 little carburetors attached to each one of your injectors. Now, the problem with the hybrid name is everybody got confused and thought that we were working on fuel injection systems for Priuses. So we needed a better name from a marketing standpoint. And if you look at it realistically, what we are doing is supercharging the fuel injection. We're adding extra energy to the fuel injection system that's already there. and getting a better overall injection result.
Well, as you said, I know a lot of people sitting there scratching their head, probably thinking, how in the world does a carburetor get injected into a injector conversation? And I like the way you tried to explain it to me last night, was as this fuel is coming down through the injector and getting ready to go out the end of the nozzle, your addition, I want to put it that way, I'm going to call it your blade addition, acts almost like a slingshot at Daytona or Talladega. It takes what's coming down through there and accelerates it when it gets toward the end of the nozzle, to the end of the blade, and through that acceleration, it makes where the direction you're aiming it within the chamber itself more effective, thus creating a positive result. And again, like you explained to me, no matter where and when, it's going to be a positive result.
Right. Well, we guarantee you will get something out of it, because on top of all of that, we have this X factor of the ability to actually index the blade. So we're sticking a protrusion down into the port, no doubt. We do that on purpose. Most of the time, we're lined up right behind the intake valve stem and guide boss. So that obstruction is already in the port. And we put this blade in front of there. We have shown that you can actually improve the airflow. Some of the power we have made in some of these engines at the top end has been because of actual improved airflow. So when people look at this, they automatically think, oh, you're putting an obstruction in the port. There's no way that that can make more power. But on the airflow alone, just aside from everything else, and we did test these separately, by the way. We tested blades that did not have the hybrid effect tuned into them, and they worked a little bit as well. So you get a little bit just from that. But then on top of that, you now can index that. You can change the angle of that blade to swirl to the right around the intake valve stem and guide boss, or to the left, or to whatever degree and intensity that your particular setup would like to have. Now in the future, we would like to see optimization where guys would be able to go in and put this on like an eddy current dyno and just hold it there and just tune each individual port. What we think you will find with some engines is there may be a slightly different index for each individual cylinder to maximize and get the most out of it. But we have not seen an engine yet that actually wanted these to run perfectly straight. They all seem to like a little bit of an angle to get the maximum result. But the key is that we can find that sweet spot. So we're not doing too much, because if you do too much, you will cut the top end flow down. So you can turn these sideways and, take 5% horsepower right out. Turn it the other way and make 5%. We've seen that.
Okay, with that being said, make sure that I'm going to make this statement correctly. You're not, when you say you increase airflow, your product is not actually producing airflow. It's just taking the airflow that's there and making it more effective.
Well, I mean, it can, because, I use the analogy of two cars going down the backstretch of Talladega can go faster than one. So it's the same thing. We put this in front of that obstruction. It's not necessarily going to actually harm the flow. It could actually help it, because you're putting a blade in front of a round obstruction, and that actually can help it. We've actually seen engine tests where the peak horsepower point went up 150 to 200 RPM. So aside from everything else that we would see at the bottom end, torque and all of that, we've actually seen the actual point of maximum horsepower go up in the power band. That would seem to indicate that it's actually flowing better. So yes, you can get that. And then on top of that, like I said, you can tune it. So we don't pay a price for the little tiny bit of energy that we tap into to create the pressure differential to aid in our fuel injection. And then the other thing too is that once this is done, see how much closer that's going to be to the intake valve. So we have people say, oh, you can't put anything in front of the injector nozzle. We have great engineers that have spent millions of dollars designing these fine nozzles and developing these spray patterns and all of this, and you just can't do that. And they talk about emissions and stuff, and of course on the performance side, we're not as concerned about that. But the fact of the matter is, if you look inside intake port, without this blade in there, you will see a line where the fuel is hitting the side of the port and turning back into liquid fuel and creating just a distinct line where it cleans the port, and it does a good job of keeping the valve clean as well. But that tells you right there that there's already something in the way, and it's the port itself. So we're saying, put this in the way, get it down closer to the intake valve. Then we also have directional aspects to our nozzle on the Gen 3. So we got a 45-degree angle. So some of the fuel goes off at an angle and it splits 15 degrees. So some of the fuel goes off at an angle so that it'll shoot to the back of the valve. And then you can also tune that. So you're tuning that at the same time when you're indexing the whole system.
Okay, so not only are we talking about making power, but we're also making the engine more efficient.
Yes, that is definitely a part of what we see consistently is that we're improving combustion. And we even see it in the spark plugs. We pull the spark plugs out and they look different. They're running cooler. Well, why are they running cooler? They're running cooler because the actual combustion process is more efficient. So that would indicate that probably the exhaust temps have gone down a little bit as well, which means your brake thermal efficiency has gone up. We don't have a lot of scientific tests on the fuel economy side of it, but we have a lot of testimony, and including myself, I've done this where I've tested it. And the least I've seen in actual real world driving is about 7%. And I've seen as high as 15% improvement in fuel economy.
Okay, with that being said, in the testing that you said you've done for yourself, how long have you been working on this project? And is it, under a patent or?
Yeah, okay, well, we got a really strong patent, and we got patents pending, including an international patent that we filed just a few months ago. Yeah, I've been working on this since 2016. The first design that we worked on, what we would call the Gen 1. The best example of that, of course, is this right here. That's what the Gen 1 was. This is a pretty crude example, and these things actually work pretty well, and these were designed to press fit onto the nozzle. So another thing that we improved greatly with the Gen 3 is that we made it a universal system. So with the Gen 3 part, 16 different brands, all the different injectors, all the 14mm based injectors will fit in this design. This one here, you had to have a different one for every single nozzle, and some of them didn't fit too well. So it became a little problematic with some of the different nozzles out there. So that was one of many things that we did to improve the technology in the Gen 3. And what you see behind me here is the Gen 3 as well. And you can see here, here's the Ram airport here, and this goes into this, we call it hyperport. It necks down slightly here so that it diverts some of the flow into the 45-degree nozzle. And we also have this ram jet, which adds some sonic waves to it to further break everything up. So it's a pretty neat system.
And how hard is it to install?
Well, that's there's a little bit of a trade-off going away from pressing onto the nozzles. When we did that, we could create a product that a guy could just pull these injectors out, put these in, and go right back in. But in order to make a universal system, you simply can't do that. You have to make the factory mounting port slightly larger. So it's about 1/8 of an inch larger. And we find that probably 95% of the time, there's plenty of material to do it. And we've even developed a special tool right here so that it can be done easily just by anybody. The tool uses the fuel rail and the existing mounting port, and it spans in between there and locks in there, and it allows you to cut just using a regular drill, wireless cordless drill, and you could just cut a perfect machine quality hole every time in aluminum or plastic, and it's perfectly aligned to the system when it's done. Might even be better than the factory in terms of alignment. And once that's done, then you go to these. We also have these adapters. So once you convert the hole to the slightly, you can see how, if you can see here, how small that is. That's how much you have to increase the size, is that little bit there. So once you're done with that, you could put these in and you could run the injectors the same as you did before. So if one guy wanted to try it, he could cut a friend's manifold, they could put them in, they could try it. And then if it works, put these in, he can continue to run his vehicle until he decides to purchase the product and do it himself. Also for testing, it's good because it means that you can go back and forth. Literally in about 10 minutes, you could go from standard to this.
Okay. So what's the next step as far as the development and the continued learning curve with your product?
Well, I think that the Gen 3 is really getting close to the pinnacle of what can be done with this technology. They are more expensive to make. They're a little bit more complicated, obviously, than the earlier, much simpler design. But with the right partner, we get the volume up. We could make some really beautiful parts, and we could probably sell, a complete kit, a V8 kit, for less than $800, and everybody would make money. And then we could sell the tool for probably less than $200. And the tool would allow a dealer, for example, I mean, he would be able to modify, untold numbers of manifolds to adapt the system. So wouldn't need to have a tool sold with every kit.
All right. With that being said, you mentioned partner. What is that in reference to when you say partner?
Well, I think that this is one of those situations. We have a patented technology. It's proven, it works. We have a guarantee, because we've seen it so many times, that if you try this technology, if you have the ability to test it, you've got the ability to install it correctly and test it correctly. And if it doesn't do anything, we'll give you your money back. And nobody wants to get rid of these. Once you feel the throttle response, just the throttle response alone is enough to make a guy want to run these. You would not believe how much better that it improves that from the existing system, but it really does. I mean, you really experience a snappier throttle, and it's counterintuitive again. It's like, how can you put something in the way of the injector nozzle and end up with a snappier throttle? Well, once again, we're slingshotting that in there. So once you get the air flowing past the blade, it can generate a lot of pressure differential between this ram air port here and the end of the nozzle. And that can actually generate more speed of the flow inside the hyperport. And that's why we call it a hyperport, and that's why we call it supercharged, because it can actually generate more speed than the air that is surrounding the blade.
So how many manufacturers, how many makes and models have you worked with so far? You mentioned your own experience. So what did you put this on that you felt the response?
Well, the Gen 1s work really well on Harley Davidsons, and we've also put them in some Hemis and a few LT1s, and it worked in every case. Most of the cases when we put them in, we got an immediate, what I would call a drop in. There was one LT1 that we put it in and we got 1 horsepower, but we saw that the air fuel ratio changed. So once we tuned the air fuel ratio, then we made about 12 horsepower. So even in that application, it ended up being very positive. That was with the Gen 1. The Gen 3s are an improvement, obviously, over the Gen 1. So we would expect that same, and my own personal experience in our 2019 Challenger is that we compared the Gen 1s to the Gen 3s, and the Gen 3s were definitely better. So we guarantee you're going to get something. We've seen the results vary from 1% to 10%. Straight up dyno tests. We have affidavits on the actual dyno tests that have been signed by people that originally didn't think it would work and then saw it work. So you're going to get some positive result because there's that X factor, you know, the ability to tune the airflow along with this. So when you get that combination and that tunability, if you're willing to put a little bit of time into sorting it out, you're going to come out with a positive result on the other end. We're sure of it.
Yeah. Well, I know that, you know, in doing a little research, I watched the video on the Harley Davidson, which was, again, it was surprising to think that, you know, that the way it's designed and everything, that it would be applicable, you know, there'd be enough room in there to make it all work. But it was, and to your point, not only were they able to improve, but they improved pretty substantially for there's something, you know, I mean, I think it was 120 inch motor or whatever. And, you know, they picked up, like, you know, when it finally got it tuned up, was about what, 3 horsepower. And he was talking about the ability to fine tune was, you know, kind of amazing to himself. So,
yeah. Well, I don't know which one you're talking about. We had several of them that made 4 horsepower, 5 or 6 foot-pounds of torque on engines that were putting out maybe 100 horsepower. The Harley engines that we actually have seen the largest gains on are the ones that are highly built up. So we've had a couple of guys that put these in 132 horsepower, highly built up, real big cams and all that, and saw 9-10 horsepower increase. So they actually were getting a higher percentage, not just the number, but the actual percentage was higher with the built up engines than it was with the stock engines. But it's positive all around. We've never seen anybody that's installed them correctly and tested them correctly not get some kind of positive result.
so where else are you looking as far as within the automotive industry, or are you looking anywhere else? I mean, is this hypothetically good for diesel engines? I mean, would it be something to be applicable there?
No,
Airplanes, whatever.
Diesel it wouldn't work on because they're direct injected. So this is a port injected system. So, you know, not for diesels. But yeah, obviously OEMs, you know, we do have a license from a company that's developing a new extremely high horsepower outboard engine called Alphadan. They're making a 650 horsepower outboard system right now to compete with Mercury's 600 horsepower V12. And so that was the first OEM license that we got. That company is still in the process of developing their engine with Mala. Mala is their partner on that project, and it's going pretty well. So there's an example of a market that's never going to be able to go electric. I'm not convinced that any of these markets are going to be able to ever go 100% electric. There's just too many problems with that. But if you were to run the numbers on trying to take a 60-70 foot boat and create enough horsepower to cruise at 60-70 miles an hour, the battery would sink the boat. So it's not possible to get the kind of performance that you need for those kind of boats. So these large outboard engines, there's a really big market, a very profitable market for them. And that's just one example. But on the aftermarket side, where this thing has a lot of potential is the fact that you've got, you know, like 1 billion port fuel injected engines out there that are running. And I think that as the government tries to force more people into electric cars and stuff, people are going to be running those cars longer and longer and finding ways to improve them. I think we could actually see the market from an aftermarket standpoint for something like this actually go up in the coming years. So the right partner, the right distributor that we could do an alliance with to get the volume of production up and get the right marketing support, definitely this could be a product that everybody could make money on. We could make some really beautiful parts for people, really high quality stuff, like I say, and probably sell the kit for less than $800. And everybody would be making money. So right now, because of the low volume, it's more expensive. The Gen 3s are definitely a lot more expensive. But the other thing I wanted to mention, Jeff, is another thing that we're doing, and we've already got one race engine company that we're working with on this, is that if you're willing to give it a try and give us data on a particular engine, then we will split the dealer cost, and we won't give them to people for nothing, because we've been down that road too many times. They swear that they're going to test it in 2 weeks, and 6 months later nothing is done. So they've got to have some skin in the game, but we'll split the cost, and then when they test, they share the data, and that could be a good start for somebody. And something we haven't talked about yet, Jeff, is the risk factors. What's the risk?
Right.
There must be people out there that are wondering, are these things ever gonna break, or do they pose any kind of risk to the engine? So we can talk about that too.
No, well, I mean, like I say, since you brought it up, I mean, we would think that there is a probability and a possibility of that hanging out inside that port. What it seems to be is right at the moment, the durability of it. Is it the product been tested enough? You feel like it run enough that you got confidence as far as its durability?
Yeah, as far as ever doing anything to harm an engine, the probability is somewhere between 0 and absolute 0.
Okay.
These components, this particular one here that's made out of 6061 T6 cold rolled, you can't bend it. I'm a pretty strong guy and I can't bend them. Now the Gen 1s and the Gen 2s you could bend, but even them, there was no risk that they would ever break and fall into the port. As you can see here, we have a mounting system that seals, obviously, but it also is a mounting system. So even in the most radical environment, it's going to be absorbing vibration, and there would never be enough vibration inside the engine to actually break down this material and cause it to fall into the engine. That would never happen. But even if you had an explosion inside the manifold that was enough to render the engine inoperable, this would survive. Because at the most, a huge explosion might bend it, but even bent, it would still work. So you have a much greater chance of blowing out an aluminum throttle plate and breaking a throttle shaft or something like that, which I have seen, than you would doing any harm to this, even with a massive explosion.
So let's go back and let's touch on this one more time. I know you explained it to us, but if somebody was to order a set of these to put on, I mean, are they recommended for use? I mean, when you're putting, if you got an engine, you want to put it on a used set of injectors, it's just an add-on, correct? And how long would you say it would take to put a set of them, to be able to, establish or run it on a chassis dyno type scenario? What would that entail?
Well, with the Gen 3s, because you have to cut the slightly larger mounting port, you actually have to take the manifold off. Then you would use this tool here. You would cut the ports, and once you're set up with that, and you can run the same injectors. That's the nice thing about the Gen 3 is once you're converted to the SFI system, you can run any injector you want. And I'm talking billet atomizers, whatever, they all will fit. So, billet atomizers, you probably know what they or you probably heard of them. They're extremely high flow injectors are used in, like pro mods and stuff like that, where they need an extreme amount of flow, up to 1,100 pounds per hour, if you can believe that.
Yeah.
Even those will fit in this system. So once you're converted over, you can run anything. Now, In the future, I think that what we're going to be recommending for people that really want to get serious about optimizing the system is to go with a little bit bigger injector than you would normally run, simply so you can focus more of the duty cycle during the intake cycle. So we want to be injecting as much fuel as possible into this system at the time when there's lots of airflow going across the blade. So, you know, you running 80% duty cycle, then you're injecting the fuel a lot of time outside of the intake cycle.
So what about the fuel you use with this product and everything? Can you notice a difference there, or you recommend any kind of special fuel for different, you know, passengers versus a racing application?
Well, I mean, the units are fully anodized.
Okay.
So you can run any kind of fuel. The actual design of the Gen 3 is designed to flow enough fuel for about 4,500 horsepower. So a single set on this to flow that and still have room for some air in there. So the system uses compressed air to explode at the end and just shear the fuel, or to vaporize it. It does one or the other if the conditions are right. So we can simply exchange more liquid fuel. There's enough space in there for some of the air, and it'll still work. So you can go from a 200 horsepower V6 all the way up to a 4,500 horsepower Pro Mod V8, and there's enough room in there for the fuel and the air. So you can run any kind of fuel. Do we have actual test data on the different fuels? No, at this point, we don't have test data on the different fuels and how they react to this. But remember, you still have that X factor. So everything else being equal, you're still going to be able to tune airflow around that intake valve stem and guide boss and pick up, you know, potentially some more advantage there. And then also let's talk about boosting too. We had one test that a guy did on a boosted Harley, and we predicted that it would do really well. And the reason why, now this was with gasoline, okay?
Right.
But we predicted that it would do really well because why? Because when you supercharge, there's a lot of heat in the air charge. So you have a lot of heat to transfer over to the fuel to create that phase change. So this just aids in that. And sure enough, that test showed that it appeared to do a higher percentage gain with the boosting than without. So the number is higher because you're already boosted up to a higher number, but the actual percentage on top of that was better. So you do not, this is not something that gets in our opinion, we don't think it's going to get canceled out by running it in a boosted engine. If anything, it will do just as well, if not better, because of the heat. So anytime we can take fuel and vaporize more of it, we're going to cool that intake charge, and that's going to help with the velocity and the packing into the cylinder.
With what you just brought into play there, have you had discussions with any race sanctioning bodies, whether it's drag racing or circle track, that you know, whether this was, you know, put in an engine, would be legal?
No, I haven't had those discussions, and we probably wouldn't do that. We'd probably hopefully find someone that would just go ahead and do it and then let them complain about it after we prove it works. That would probably be the way to do it. I've looked at the rules on like the Pro Stock, for example, and it appears that the rules would not be violated in Pro Stock. They dictate what kind of injector you have to run, which is a Holley injector.
Right.
But you can modify the manifold any way you want. And with the Gen 3, it actually is a modification of the manifold. We don't touch the injector. The injector itself is exactly the same. So you're on the rules of Pro Stock, you're not allowed to actually change the diffuser on the nozzle of the injector. And we don't do that. So it appears that it would not violate anything on that in that class.
That would comply with that. That's good.
Yeah.
folks out there, I know you, a lot of you been sitting in there, I think, listening and understanding what we're discussing today. And if you got any questions, please fire away. We're getting closer toward the end of our program anyway. So, we want to make sure you're involved. So if you got any kind of questions, for Reggie or, for whatever man or whatever, we didn't maybe talk about something you felt like was relevant, please send us some questions. And let's see here. The other thing is, Reggie, we do have a video that we could run and maybe also make it a little bit more people to understand a little bit more.
Yeah, you can go ahead and run that video now. It's an animation to show how the process works as the air goes across the blade.
What about that, Reggie? I think that really it gives us a picture to work off of, and really a great illustration of all the things you've been talking about here this morning.
Yeah, I mean, it's basically showing the hybrid aspect of what this is. It's such a simple idea. And, something I haven't said before about this that people need to understand. We were talking about the risk a little bit. Understand that we create these improvements and we create a new tuning aspect that has never been introduced before. And we do it without a single moving part. There's nothing to wear out. It will never break. It'll never require maintenance. It actually reduces the peak temperature of the injector itself, which, to the extent that port injectors need some maintenance, it comes from those peak temperatures, which causes varnish to attach to the pintle. And over time, that can affect the flow. So we figure we're probably dropping the peak temperatures down 40 degrees, which would virtually eliminate even the little bit of potential maintenance that you would have with a port fuel injector. So we even go the opposite direction on that. So everything truly is better with this system. Like I say, you're going to get something positive out of it no matter what. Cooler injectors, obviously the tunability, and like I said, there's nothing to wear out or break. So it's a zero risk opportunity to make power in a new way, and it's new power too. This isn't power that you could just buy some other product and make that power, and then all of a sudden this wouldn't do anything. We have never seen that. So whatever other things you've done, this would add to that.
Yeah.
Yeah. So.
And I think anybody that's sitting there looking at what we just saw, that it gives a better explanation or understanding of probably how it's been directional. There you go. That you're being so much more directional with, your fuel flow, that's where the power gain comes from, as well as your efficiency. Everything about it, it's like I say, I don't want to say it's free, but it's one of those kind of add-ons that don't come with any kind of negatives. I mean, we talked about this last night. When you discuss it, if it don't break and it doesn't, if it doesn't have a negative and it's all positive with the guarantees that you are standing behind your product with this Gen 3, to me, it's a win-win.
Yes, and it's a prime opportunity. Understand that in this business, internal combustion engines are perceived as being mature. I actually don't believe that. I actually believe the internal combustion engine, and I have some proof of that. We have a lot of other projects we're working on that show that the internal combustion engine can be way more efficient, simpler, cost less. So it's got a long way to go. But we haven't seen a totally new potential add-on, an entirely new concept in that in probably 30, 35 years in this business. Okay. So everything that you see now, different supercharged, and it's all just, nibbling away at little aspects of things that have already been done a billion times over. This is actually a new approach. So this is a new opportunity for ourselves, obviously, and for any kind of a partner that we would partner up with to introduce something new for customers to be able to do to improve the performance, and at the same time, make their engine more efficient at the same time. So, like you said, it's all positive. Of course, we're trying to sell this so that everybody's going to say, well, sure, that's what you're going to say. But we really stand behind that. You go to the website, you can see all the test results. You can see people have signed affidavits. It's all there. This is not smoke and mirrors. This is something we've proven over a long time. And where it's going to go from here, potentially, is that you're going to be able to have these little control arms. The Gen 3s are designed so that a little control arm will snap onto the flange, and then you can link those up, put a stepper motor on there, and have a computer control them and be able to actually adjust on the fly. So at low RPMs, when you might want to have a lot of swirl, it would be able to do that, and then instantly adjust it for torque and power.
And folks, what Reggie's talked about since we came on, this really connects back to the same theories that were established when carburetors were in their infancy. And we both agreed the laws of physics haven't changed. All we've done is just make them look a little bit smarter, but the laws of physics and what we're trying to do with fuel and compression and everything is just been more efficient, made more efficient because of both the applications and things that were learned in the very inception of an engine, and now it's perfected today. And this Gen 3 is just another example of that. Really appreciate it, Reggie. Thank you.
Well, thank you for your time, and thank you for the opportunity to do this. And hopefully we've left a few people more informed and maybe more curious about what we can do here, and about the business opportunity part of it too. It's a unique opportunity. We have a very strong patent, and like I said, we do have others that are pending now. So it took us 4 years to get the patent. I don't know why it took so long. I personally have 7 patents. I've never had one take 4 years, but in the end, it ended up being the strongest patent we've ever gotten. So that part of it made it worth the wait, I guess. But yeah, we're proud of it. And it's something, if you have a race team and you've hit a wall, okay, and you're like, what else can we do? This is something you should be looking into, because it's no risk. We have never had these so much as trip an engine light on a car. It is not going to do any harm to an engine to try it. So there you have it. As they say, wherever the road of life takes you, there you are.
Well said.
Thank you very much, Reggie. Thank you, Jeff. Great webinar. It has been recorded. It will be posted later on the ePortrait platform. Please go on ePortrait. You'll find the Gen 3 products right there. You can click on it, connect with Reggie. We build this platform for you. We're live every Wednesday. The platform is open 24/7, 365. So take advantage of it. We will be back live next Wednesday. We'll talk piston rings, modern piston rings with Mare Motorsport. So thank you very much for being with us today. Let's go racing. Bye-bye.
All right. Thank you.
ePortrait is a digital platform that we've created basically to make life easier in the business community of auto racing.
ePortrait, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, All you need to do is click on request more information, and then from there it is forwarded directly to the buyer or to the supplier.
ePartrade really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
My name is Shadron Sisson. I'm one of the owners of Electrified Garage. So the Shop Monkey software is great since we have the multiple locations. We can dive into each other's location and help out with appointment taking, inventory, customer communication. I can jump into Florida and help out and make an appointment down there, and vice versa. They can make appointments down there for us up here. And then by using our inventory, they can see if we have the parts, and they can get the parts ordered before the customer even comes up here.